Hello Math 8 students. Today we are going to be doing a calculator exploration, specifically some relationships that we see when we have parallel lines. So unlike our other calculator explorations, we're going to get started today by creating a line, not a polygon. I'll let you go ahead and do this with me. I trust that you can follow these directions. So menu, option 4, points and lines, and I'm just going to choose option 4, line. Just like usual, it'll pop up the little icon telling us how to create a line. All we really have to do is just click on 2 points and that will create the line. I'm still in that line creation, so I'll hit escape. A few things to note about this line. So eyes on the screen. One thing, if you don't like where the line is, you can pick up the line by clicking on the point. So if I just hover, press and hold, now I can pick that up and move it around, and that will change the location of the line. If you don't like the way that the line looks, like if you wanted it to be more angled, you'll want to come over to the other side of the line and click on the other side, again press and hold, and then you can change the angle. Notice that that point is not changing. The point is still determining where the line is going to be, but now I can change how it looks. I can also, as I've grabbed on this end, sometimes this is finicky, I can also pull it and extend it longer. Just to kind of show that even though the line stops here, it doesn't really end. I can just drag it out. So if I want a bigger visual of that line, I can drag that out. So students, go ahead and create your line. Have it somewhere near the bottom-ish of the screen. It doesn't need to be, perfectly horizontal. Have it extend through most of the screen, so make any changes that you need to. I'm going to pause the recording as students do that. Okay, now here's what I want to do next. I want to transform this line by translating it. So you might remember from our previous calculator exploration that to do a translation, I need to create a vector first. So with me now, we're going to go menu. Option 4, points and lines, does include a vector. That would be option 8, a vector. So to create the vector, you just need to click on 2 points. I'm going to click kind of out of the way of things, so I'm going to click here, and I want it to kind of go in that upward right-ish direction. Doesn't have to be too big, because however much it translates, that's how far this parallel or this line is going to translate, and so I want them to, I want it to fit on the screen. Still in vector creation mode, and I don't want to be, so I hit escape. And now that we have our vector, now we are ready to transform this line by translating it. So I think you can do this with me as well. Menu, option 8, transformation, and option 3, translation. If you need a reminder, you can just hover. First click the object that we want to translate, then the translation vector. So I want to translate this line using this vector, and now it creates the new line for me. Hit escape because it still is trying to translate things, and I'm done translating things. Everybody's screen is looking mostly pretty good. So a few things, and then I'll have you peek in on your neighbor. A few things to note. Remember, just like before, when I did my translation using a figure, I could change the translation just by changing the vector. So if you need to make adjustments to your vector so that your line appears on the screen, then go ahead and do that. The other thing that I would like to point out, and this is what's pretty cool, is I can change this original line. And you're going to notice whatever changes I make to that line, it is making those same changes to the image of the line. As we adjust the pre-image, those same changes are happening. So go ahead and explore with that as you're also peeking in on your neighbor, making sure that they don't have any questions, pausing the recording as students get caught up. What do you notice about these lines? There's a vocabulary word that we can use. What do you notice, Grant? Perpendicular. What does perpendicular mean? Are you sure that's what perpendicular means? It's another P word. Who wants to help them out? Gideon? Yeah, they're parallel. Now with that reminder, Grant, do you remember what perpendicular actually means? They cross at 90 degrees, yes. So are these ones perpendicular lines? No, because as you said, they never ever cross. That makes them parallel lines. So these are parallel, and a great way to observe that they're parallel is whenever I'm making any changes, you can see that those exact same changes are happening to the other one. And no matter what they look like, they are never going to cross unless, of course, I translate it in the exact same direction as the vector. Then they're not crossing, they are becoming the exact same line. Right? So we already noticed that that would happen, I think it was back in lesson 9, that when I take a line and I translate it, it is going to create a line that is parallel to it. So nothing new here, but now I am going to be creating an additional line that is going to intersect both of these lines. That line is going to be called a transversal. So let's recap. What do we have so far? We have a set of parallel lines. We know they're parallel because I translated this one to become this one. But there's not enough information here. I want to do some more stuff. So I need to create an additional line that is going to go through these. So you can do this with me. Menu, option for points and lines, and we are just going to create another line. And I want it to go through these ones. So I'll just start down here, go up there, and escape so I'm no longer in line creation mode. And that is why, folks, I did encourage you to make it look somewhat like mine. If it doesn't, you're going to have to make some changes to your diagram so that you can have parallel lines and another line that goes through them. Here is some terminology that you need to know about this. Again, we have a set of parallel lines, but now we have a line that goes through them. We call this parallel lines cut by a transversal. Transversal just means it is going to cross both of them. And we're looking for certain relationships as we see the parallel lines cut by a transversal. Specifically, I want us to be able to measure one angle, and I want to see if we can figure out all of the other ones. So I'm going to pause here, wait for everyone to get caught up. So what I want to do, like I said, I want to measure just one single angle, and the one single angle is going to be down here. I want to measure the angle between this line and that transversal that cuts it. You guys could probably maybe do this with me. If you're unsure, maybe just watch first. So menu, measurement, angle. Here's the part that I want you to be really careful about. I want you to observe that when I am measuring the angle, I need to be really precise about the points. So I'm going to choose this point because that helped to create the line. The next one, you notice that it says point on. If I keep going, do you see how it changes to intersection point? That tells me that I'm actually choosing the correct point where those two lines intersect. And then, again, stay on the line, make sure it says point on. Otherwise, if you're off just a little bit, you're not measuring the correct angle. So make sure you're choosing point on. It doesn't matter where it is on that line, but choose point on. Now we have an angle measured. I'm going to hit escape. Just moving that label out of the way so that I can see. And this angle is measured 109.1. 109.1. You can see as I make changes to this line, you can see that it is dynamic and it is remeasuring it. Just to make things easy, I'm going to adjust that so that there's no decimal. It'll make your life a little bit easier. Try and adjust yours so that there is no decimal. Again, I did that just by changing the angle of my original line here. Based on that, and just help me work through my own diagram, based on that, can you figure out some other angles? I'm going to pause the recording as we discuss for just a second. Here's that same diagram, but now I can write on it. What are some other angles that you know? And how do you know them? Emily, will you go point? How do you know that? Okay. I am really impressed by that. That's something that I was hoping that we could work towards, something that we would learn by the end of the exploration. But Emily is making the claim that this angle here is also going to be 105 degrees because they're parallel lines. Let's explore that a little bit further. Before we try and jump to those conclusions, there are some others that I know for sure. Without having to guess about anything about parallel lines, I know for sure. Dylan, if you need to go up and point, go point to one. Okay. Which one? This one. Okay. This one is 75 degrees. Again, he went with the claim that we know that a line is a straight angle that is going to be 180 degrees. So 180 degrees. This much is 105, so we subtract 105 from 180 and we get 75 degrees. That, please put this in your brains. We haven't given it this vocabulary name before, but that is called supplementary angles. We'll put it on our paper next time, but put it in your brain now. Supplementary angles. Supplementary angles sum to 180 degrees. A way that I remember this is S for supplementary is like a straight line. A straight line is 180 degrees. They both start with S, so a straight line is supplementary 180 degrees. So we haven't used that vocabulary word. We've just said that they add to 180. That just means that they are supplementary. Who can tell me another angle based on what we know now? Davin, go ahead and point if you need to. How do you know that this one is also 75 degrees? Okay, so we're going to continue to use that same property as before, recognizing that this is also a straight line. So that means a straight line has an angle measure of 180 degrees, which means that we have, once again, supplementary angles. There is an additional justification. What is an additional justification that I can use to show that this is 75 degrees? Okay, this was on a previous lesson and a previous test, so quickly check in with your tables. What is the other property that I could use to justify this? Who thinks they know now after checking in with their tables? A few more hands. Carter? Yeah, vertical angles. You guys remember that property? You should. Vertical angles. Just not the name. We know that they're vertical angles because we have intersecting lines. Remember, that means that this, as you recognize it, that's a 180 degree angle. That also means that this line could be rotated 180 degrees and land on itself. And as that happens, guess what's happening to this angle? It's rotating and landing here. So we also know that this one is 75 degrees because of vertical angles. So it just kind of confirms and proves that what we already know because of supplementary angles. It's just one additional way that we can show it. Okay, what about this last angle? A couple ways I can show it. Tell me a way that I can show and figure out what this angle is. Esther? Yeah, we can prove it two ways. We know it's 105 degrees by one, vertical angles, but we could also continue to use that supplementary angles, knowing that that is going to add to 180, just like this going this direction is going to add to 180. So multiple proofs there using vertical angles and supplementary angles. And now let's address the claim that this is also 105 degrees because parallel lines. What do you guys think about that? Talk at your tables. Do you believe that that is enough to show that that angle is also going to be 105 degrees? What can we do with that information? I'm going to pause the recording as students discuss. Ready, set, go. Okay, what do you think about this claim that this is also 105 degrees? Do you agree with it? Okay, prove it to me then. Gabe. Yeah. How did we create this line to begin with? Why does this line even exist? Dylan? We translated it. So that means I could take this line and translate it, and then what's going to be happening with that angle? That angle is going to be translated. Let's test that out. I'm going back into my calculator. First, why don't we test it out and let's measure all of these angles, and then we can test out our theory and measure these angles here. So I already know that this, for me, and my diagram that I showed on the screen is 105 degrees. So I'm going to go through menu, option 6 measurement, option 4 angle. I'm going to continue to measure all of these other angles. So this line to this intersection point to this point on this line, and it did measure it, it just put it in a weird spot. You might see some of this too, folks. Can we talk about what we see here? Why does it say 74.99? I thought according to my diagram it was supposed to be 75. What's happening? Let's review because we've seen that before. Joshua, what's happening? Yeah. Yes. Yeah, this one was rounded because I've got my float set to a certain way so that it will round. This one is not rounding as much. So just to demonstrate, we've seen this before, if I go in and I adjust my settings and change my float to a little bit higher, I'm going to see that both of those end up having some extra decimals that are being measured. So to fix all of that, I'm going to change my float settings to 3. Feel free to do the same. If I adjust my float settings to 3, they're going to be rounded in about the same way, and I'll be a lot happier with those results without having to see the float to 12 and seeing all those extra decimal places. Go and do that with your own. I'm going to continue measuring. And each time I measured, you're going to notice that it just continued to place those measurements one on top of the other. So I'm just reorganizing that. Now the calculator does agree with what I just showed on paper, understanding that the float is being rounded to create those measurements. Okay, and now testing Emily's hypothesis. These angles are going to be the same because this is just a translated version of this line. So I'm going to test out and measure this angle in my calculator. Menu, measurement, angle. I already have a point that's on this transversal line. I'm going to go to the intersection point and then a point on this other line. And again, hit escape because I'm still in measure mode. And notice, whatever this angle is, that one ended up being the same, even if I readjust my float to show additional decimals. Those decimals are overlapping each other, but you can see, even extending it to see all those extra decimals, it does measure to be perfectly the same. I'm readjusting that float. I don't like having that much going on. And now that we know this angle measurement, what can we assume about some of these other ones? Do we know what this one's going to be? 105 degrees by what? Give me a property. 105 degrees because, Joshua, vertical angles are congruent. I also know then that this angle is going to be 75 degrees. How do I know that this one is going to be 75 degrees? Grant. Ooh, you're trying to make another claim that because they're parallel lines, we can now make these assumptions. You are correct. We're going to call that corresponding angles. And it makes sense, right? Because this angle is just translated, so it corresponds, this angle here corresponds with the pre-image. So we're going to call that corresponding angles. This angle is 75 degrees. This is its corresponding angle, so it is also 75 degrees. I'm going to prove that with another measurement. Point on, intersection point, point on, and of course it just overlapped. But yes, 75 degrees because of corresponding angles. There's another way that I can prove that it's 75 degrees. What is another way, another property? Let's see if you guys can remember some names. What's another property that I could use to show that this is 75 degrees? I wrote it down here. When they add to 180 degrees, that is called supplementary angles. So in addition to this new proof of corresponding angles, I can also use this property that is old and familiar of supplementary angles that add to 180 degrees. Let's measure some more. I bet I know what this one's going to be. This angle here is going to measure to be what, Tanner? Give me a reason why. Supplementary angles. So I'm assuming that you're adding 105 and 75 to get 180 here. Who can tell me another reason why they know that's 75 degrees? Joshua. Corresponding angles. You're saying that this angle translates up here, so it's corresponding 75 degrees. Who can tell me one more reason? Davin. Vertical angles. We already know that this one is 75, so do I really even need to measure it to prove it? I proved it 3 ways now, but let's do it anyway. I like to prove a point angle, point, intersection point, and a point on. Of course, it overlaps it with the other ones, but yes, it is 75 degrees. And multiple ways that we could also prove this one, corresponding vertical angles and supplementary angles. Let's go ahead and measure that one as well. And of course, it just overlaps it and places it over. That is better. If you are with me, if you have made all of these same adjustments, let's play around. Let's have some fun. What happens if I change this original line? What do you notice is happening to all of those angles? All of those angles are remeasuring and changing at the same time. This is 109 now, this is 109. This is 71.5, this is 71.5. So again, we're seeing some of that weirdness because of the float. But I want to point out all of those interesting relationships we have because of those parallel lines. That is it for this calculator exploration. Thanks for watching. We'll see you next time.